Good morning to all my physics learning friends. Today we will try to discuss a few things about the axial forces or the axial shear forces. So, what exactly the axial forces is? The axial force actually acts along the centroidal axis of the member, and this may also be considered if it will act if the force acts along the plane which is perpendicular to the centroidal axis, and this is known as the shear force. And the moments that is also along the direction which is perpendicular to the centroidal axis. And as you know that the torsion that is also that acts along the centroidal axis. So to understand these all, we need to consider a member, a one dimensional member. In reality, actually these are of the three dimensional structures or the members, but in order to in the but the other two dimensions are relatively much smaller. When the loading on such a member is on a plane same as the member itself, let's say it is a two dimensional member, as here it is shown in the figure A. We have a two dimensional member, and in such a cases the internal forces also lie on the same plane. The internal forces on any cross section can be expressed with two orthogonal forces, and the force components are also given here. The first force component F1 which acts along the x axis, and the second force component which acts along the y axis, and the moment component which is also working here. So this will be perpendicular to this F1 force. So if we will cut this member from this point, any of the point, so it will be like this and in the middle there is the centroidal axis. So this force which will act along this centroidal axis is known as the axial force. The force which will work along in the perpendicular to this centroidal axis, that is in the direction of F2, so that force is known as the shear force, the force which will act on a plane which is perpendicular to the direction of the centroidal axis. So that force is known as the shear force, and the moment is also working along this particular force, mean to say it is just perpendicular to the centroidal axis. So this is in the case of the two dimensional plane. To understand and the in the different members, if we will consider some another example of a three dimensional member. So here you can see a three dimensional structure of a member is given, and we can understand with the help of this. So if we will cut this particular member uh, for this 3D structure from this middle, we will consider from this point. If we will cut the member, so here it is a plane with this plane is perpendicular to the centroidal axis, and here in this diagram we can see that this is the centroidal axis, this is the centroidal axis, and the plane, this particular plane we have cut, and this plane is perpendicular to this centroidal axis. This is so the force which will act along this particular centroidal axis is considered as the axial force, and this particular force which is acting along this plane, and this particular force, so these forces are the shear force. So these all are the perpendicular to this the plane. So we can say what exactly the axial force is and what is the shear force. So I hope hopefully it is very much clear to you people that this is a three-dimensional plane, and the moment which will also act along this, it is just perpendicular to this axis, centroidal axis, and the both the shear force will also apply in the direction of this plane, okay, which in this plane. So here you may consider that if this fx is along this x axis, fy is along this y axis, and fz is along this z axis. So these are the shear forces and the moments which will work along the directions perpendicular to the direction of the centroidal axis. So hopefully you getting this, and in further in the next lecture, in my next video, you will see much more about this mechanics and the mechanics of solids. Thank you. Thanks for watching.